Unmanned aerial vehicles, or UAVs, have revolutionized modern warfare and surveillance with their advanced capabilities and operational flexibility. These drones, ranging from small handheld models to large aircraft-sized systems, serve multiple roles from reconnaissance to active engagement in combat zones. The technological evolution in UAV design has greatly expanded their application in military and civilian sectors alike. This has prompted nations to invest heavily in developing superior drones to maintain a strategic advantage. UAVs offer a high degree of situational awareness, can operate in environments too risky for manned aircraft, and are cost-effective in terms of both operations and maintenance. Their ability to gather intelligence and relay real-time data enhances decision-making processes at all levels of command. Modern drones are not only tools for aerial surveillance but also for complex autonomous missions that require minimal human oversight. The following sections will delve deeper into each of these drones, comparing their specifications, operational uses, and strategic value in modern warfare. DRDO's Archer drone is a testament to India's growing prowess in aerospace and defense technology. Designed for reconnaissance and tactical missions, the Archer is built with stealth features that minimize radar detection, making it ideal for surveillance in hostile environments. Equipped with state-of-the-art sensors and communication systems, the Archer can transmit high-resolution imagery and real-time battlefield data back to command centers. The drone's integrated artificial intelligence assists in processing vast amounts of data, aiding in quicker decision-making and increased accuracy in target identification. The propulsion system of the Archer drone features a hybrid engine that combines electric and fuel-based power, extending its range and flight duration. This adaptability, combined with its sophisticated design, makes the Archer a formidable tool in modern warfare. Northrop Grumman's N-Raven emphasizes robustness and payload capacity, making it suitable for both reconnaissance and direct action missions. The N-Raven's larger frame allows it to carry more substantial payloads, including various sensor packages and even small arms systems. The drone features an advanced multispectral sensor suite that provides thermal, infrared, and visual spectrum capabilities, enabling day and night operations with equal proficiency. Its high-definition cameras and electronic surveillance equipment allow for detailed intelligence gathering, critical for planning and executing military operations. The N-Raven's high-efficiency jet engine provides greater speed and agility, making it an excellent choice for missions requiring rapid deployment and extended coverage. Section 4. Comparative Analysis. Archer versus N-Raven. The size and weight of both drones differ significantly, with the N-Raven being larger and capable of carrying heavier payloads. The Archer's hybrid engine provides a balance between range and stealth operation, while the N-Raven's jet engine offers speed and extended range. The Archer is suited for covert, prolonged surveillance missions, while the N-Raven is designed for quick response and versatile operational roles. Navigation systems in both drones are state-of-the-art, but the Archer features a more robust setup with its integration of multiple satellite navigation systems and an inertial backup. The N-Raven's emphasis on automation and sophisticated autopilot features supports its role in complex, dynamic combat environments. The Archer's stealth features and adaptive configurations make it ideal for tactical reconnaissance and targeted strikes in sensitive areas. Section 5. Tactical and Strategic Applications. The Archer, with its stealth technology and versatile payload options, excels in operations that require discretion and precision. It is particularly effective in gathering intelligence behind enemy lines without alerting opposition forces. The N-Raven, with its robust design and extensive payload capacity, is well suited for more aggressive roles, including direct combat engagements and real-time battlefield surveillance. Strategically, the choice between these UAVs depends on the nature of the mission and the operational environment. The Archer is preferable in scenarios where stealth, prolonged surveillance, and precision are required. In contrast, the N-Raven shines in fast-paced, high-intensity operations where its speed, payload, and resilience are necessary. Section 6. Conclusion. Choosing the right drone for the mission. Both the DRDO's Archer and Northrop Grumman's N-Raven represent significant advancements in UAV technology, each engineered with distinct capabilities for specific operational needs. The choice between these drones should be guided by the specific requirements of the mission, considering factors such as stealth, payload capacity, operational range, and environmental resilience. For missions requiring discrete surveillance and operational flexibility, the Archer stands out with its stealth features and adaptive design. Conversely, for scenarios that demand robust performance and a heavy-duty approach, the N-Raven's capabilities make it the UAV of choice. Choosing the right drone for the right mission will remain a pivotal factor in leveraging the full potential of UAV technology in future conflicts.